We are discussing sets. Set are a collection that contain no duplicate elements. That is, there will be no element in your set at any given point where the value of E1 is equal to the value of E2. And it can contain null element, but given there can be no duplicates, hence you can have at most one null element in a set. As implied by its name, this interface models the mathematical set abstraction. We will cover hash set and tree set because these are the ones which are used more. At this stage, these are the ones we should be able to understand and write programs on. So hash set, it is used to create a collection that uses a hash table for storage. Hashset stores the elements by using a mechanism called hashing. Hashing is something I have discussed in the first week, where I mentioned that every object in Java is stored with a particular hexadecimal value, which is its hash code in memory. So that technique is used by Hashset for storing the elements. It doesn't allow duplicates. If you add a duplicate element, the old value would be overwritten. So it's not that you would get an error, but if you try and add a duplicate value, the previous one will be overwritten. So there will be only one instance of that value at any given time in a set. Allows null values, but if you insert more than one null value, you would still have only one. It is non-synchronized. It doesn't maintain any order. Major difference between list and sets. In sets, for this particular implementation Hashset, there is no order maintained. Elements are inserted on the basis of their hash code. What we need to understand that a program on my screen and a program on your Eclipse, it can give different output when you try and print out Hashset because the hash codes can be different. So it is kind of a random output that you will get. There is no guarantee that your elements would be printed out in a particular order when it is hash set. It is preferred for search operations. The efficiency is good when it comes to searching. We'll have a look at the example. But first, let's understand another implementation of set, that is Treeset. Now, as we see from the hierarchy, Treeset is a child of sorted set. And there is another navigable set interface, which I have not put on the main hierarchy because it would have got very confusing. But here you can remember that Treeset gets its properties from sorted set as well as navigable set. The minute we say it is a child of sorted set, we expect some order to be maintained. So in Treeset, no matter in what order you insert the elements, whenever you try to retrieve the elements, you will get them in ascending order. The way it stores it at the first place is a sorted order, which is ascending. You don't need to explicitly do a sort. That is the advantage with Treeset. It contains unique elements, just like Hashset. Access and retrieval times in this case are quite fast. The difference is Treeset does not allow null element. Hashset allows at most one null element. And just like Hashset, Treeset is also non-synchronized. So two implementations of set that we understand. One is Hashset, where null values are allowed, at most one, duplicates are not allowed. The mechanism it uses is hashing. There is no order maintained. The elements are inserted on the basis of their hash code. Hash codes can be different on different machines. We understand that, memory locations. Hence, we cannot guarantee the output in which order the elements would be printed. When we come to Treeset, there is an order maintained, ascending order. It doesn't allow null elements. It also contains only unique elements like Hashset, and it is non-synchronized. So these are the two implementations of set we'll see. And now let's go to Eclipse and look at the examples.